Previously, we were looking at arithmetic sequences and series, and in those series and sequences, we were always adding a constant value between successive terms. Well, sometimes you don't add all the time, right? You might multiply, and in the case of multiplying between successive value or between successive terms by the same number, we get a geometric sequence. Okay, so a famous example with this is bacteria. Okay, and so you can sit and count bacteria, but the idea is that in this example, if you look between successive observations, right, we are saying there's 3. Okay, now from 3 to 6, that is either plus 3 or times 2. I don't know which one is relevant. Next, I have plus 6 or times 2. So it's not arithmetic because the constant or the difference isn't constant. Okay, but if I look between now 12 and 24, that continues as multiplying by 2 pattern, and that even holds from hour 3 to hour 4. Okay, so then the question is, how many bacteria are present after 1 day? Well, we will get there. Okay, not going to do it right now. But the idea is when we look at a geometric sequence, between successive terms, we multiply by a common value, and that is called a common ratio. Okay, and specifically to determine the common ratio, we have to take this previous or the next term divided by the previous term. Okay, so just so we're clear about how to get the common ratio, it's next divided by current. Okay, and I'll even write that out. It's next divided by current. Okay, and then you always want to compare to make sure they're the same. Okay, so if we have a common ratio, then we can express the sequence either in non-recursive form or recursive form. If we have it in non-recursive form, all we have to do to generate the nth term is take the first term and multiply, there's a multiplication symbol hidden there, by the common ratio n minus 1 times. Okay, because we already have the first term, and then to get a second term, we would multiply by r, so on and so forth. Okay, recursively, it's pretty much identical, but it's just, instead of having the exponent of n minus 1, you just have it as a coefficient. So you just do a sub n minus 1 times r. Okay, and you should have a initial starting point defined as well. Okay, so as some examples here, if I look between successive terms here, the common ratio here is 20 divided by 80, which is 1/4. Between 20 and 5, so it'd be 5 over 20, which is 1/4. Okay, and the next term that holds as well. So I'm going to say yes, this is geometric with r as 1/4. Okay, now the reason I mentioned that you should check the common ratio at least 3 times is because here we might be fooled into thinking, okay, I multiply by 8, here I multiply by 8, but then the next time I multiply by 10. So this is no. Okay, you don't have a geometric sequence because your common ratio is not 10 or is not 8 or not constant throughout the entire thing. All right. Practice writing the nth term of a geometric sequence. So first job is to say, okay, well, the nth term, if I do non-recursive form, it's going to be a1 times r to the n minus 1. Okay, well, an is going to be 4 times, now I need to figure out what r is. Okay, so if I take 5 divided by 4, that should be the same as 25 over 4 divided by 5, which is the same as 25 over 16 all divided by 25 over 4. And it is. You can do the math out, but these are all equal to 5/4. Okay, so I would say that this is 5/4 to the power of n minus 1, and I would be done. Okay, recursively, if I do it recursively, I should have an is a sub n minus 1 times my common ratio, which is 5/4, and I should also specify the starting value as 4. Okay, so either one, I think this one they may have meant the second or this first form more so than the recursive form, but nevertheless it doesn't hurt to do both forms. Second second, third example, third example, some number of example. We're given a 2 and a 5. Okay. So A2, which is 54, this would be whatever A1 is times R. Okay. And then A5 is this number. And this would be A1 times R to the 4th. Well, how do I progress from here? There isn't really a sound way to go forward, but what you could try is a little bit of substitution. Solve for one of A1 or R, substitute it in. So I'm going to say let's divide by A1. So 54 over A1 is equal to R. Substitute that in over here. Let's see, so we get A1 times 54 over A1 to the 4th. Okay, and so then if I simplify this, it's not going to look extremely pretty right now, but I promise you it'll work out relatively nice in the end. 54 to the 4th is a big number. I'm just going to leave that as a big number. 54 to the 4th over, and then if I simplify this, this would be A1 to the 3rd power. And now solving this, I'm going to write A1 to the 3rd power is equal to 54 to the 4th over 182.25. Okay, and now comes the calculation part. So I need to type this in my calculator and then undo the 3rd power by cube rooting it. So let me just come up here. A1 to the 3rd is going to be 46656, and then if I take the cube root of that, I get 36. Okay, and then consequently, remembering that R is that 54 over A1, R is going to be 54 over 36, and if I simplify that, I believe I get 3/2. And then, so I found R, I found A1, and now I can find AN by saying that AN is going to be 36 times, which is A1, okay, A1 and then R to the n minus 1, times 3/2 to the n minus 1. Okay, so let's recap what went on here. Okay, if I'm given this information, it's useful to write that out in terms of the geometric sequence formula, the non-recursive part, that is. Okay, and then with each of those, what I ended up doing was I solved for one of the two variables and substituted in a lot like a system of equations, but here it's just not linear. Okay, but nevertheless I can follow that through carefully. I found what A1 is and then consequently what R is, and that enabled me to write out my nth term sequence. All right, we have to finish that example that we started with because we did not talk about it, and so I want you to pause the video, try it out on your own, and resume the video when you're ready to hear the solution. And here's my solution. Okay, I recognize the common ratio is 2. You begin at 3, and then your recursive formula, or your explicit formula, your non-recursive formula would be A1, 3 times 2 to the t. Normally we have t minus 1, but since we're starting at times 0, you don't have to change it. It's just going to be t. And so this accounts for the starting at 0. Okay. Nevertheless, with this, if you then substitute in, 24 and say, okay, well, what's the population 24 hours after, which is 1 day? 50 million bacteria. Ew. So moral of the story, wash your hands. Okay. But nevertheless, the idea here was to recognize the common ratio, your starting value, and then get your nth term set up and use that to solve what is being asked of you. Okay, so geometric sequences, again, you are finding a common ratio and using that to find the terms later in the sequence.